Natural disasters are events that are caused by natural phenomena, such as geological or meteorological processes that can cause significant damage and loss of life. These events include earthquakes, hurricanes, floods, tsunamis, wildfires, and other natural phenomena that can cause catastrophic damage to human populations and infrastructure. And today, we will show you one of the natural disasters that had a great impact on the year 1958. A great mega tsunami. Believe me, it's going to be worth your time, so stay tuned. While disasters may seem like a daunting topic, we believe that educating ourselves about the potential risks and learning from past events can actually make us feel more empowered and prepared for whatever comes our way. By staying informed and taking simple steps to prepare, we can minimize the impact of disasters on our lives and communities. From creating emergency kits to knowing evacuation routes, small actions can make a big difference in our ability to respond to disasters. So let's start with an overview of natural disasters. Natural disasters have been a significant focus of academic research, particularly in the fields of environmental science, geology, and meteorology. Scholars have sought to understand the causes and effects of natural disasters, as well as the best strategies for mitigating their impact on communities and ecosystems. So why do such incidents take place? One of the primary causes of natural disasters is geological activity, such as earthquakes and volcanic eruptions. These events occur when the Earth's tectonic plates shift and release energy, often resulting in seismic waves and other forms of destructive force. Researchers have studied the geological processes that lead to earthquakes and volcanic eruptions, as well as the ways in which these events can be predicted and prepared for. Meteorological processes also play a significant role in natural disasters, particularly in the form of extreme weather events such as hurricanes, tornadoes, and floods. These events can be caused by a variety of factors, including changes in atmospheric pressure, temperature, and humidity. Researchers have studied the patterns and causes of extreme weather events, as well as the ways in which they can be predicted and prepared for. The impact of natural disasters on human populations can be devastating, particularly in vulnerable communities that lack the resources to prepare for or recover from these events. Scholars have studied the social and economic impacts of natural disasters, as well as the best strategies for responding to them and providing support to affected communities. Though, one approach that has gained traction in recent years is the concept of disaster risk reduction, which aims to minimize the impact of natural disasters by improving preparedness and resilience in vulnerable communities. This approach involves a range of strategies, from early warning systems and emergency response planning to infrastructure improvements and community-based disaster preparedness programs. Another important area of research related to natural disasters is the impact of climate change on the frequency and intensity of these events. Climate change is expected to increase the frequency and severity of extreme weather events, as well as the likelihood of other natural disasters, such as wildfires and sea level rise. Researchers have studied the complex interactions between climate change and natural disasters, as well as the potential strategies for mitigating the impact of climate change on vulnerable communities. And among natural disasters, tsunamis are another one which is far more devastating. The Alaskan Megatsunami is a natural disaster that occurred on July 9, 1958, in Lituya Bay, Alaska. The event was triggered by a massive rock slide that occurred on the northeastern shore of the bay, which resulted in the displacement of an estimated 90 million tons of rock and ice from an altitude of approximately 3,000 feet. The landslide generated a wave with an estimated height of 1,720 feet, which propagated across the bay and caused significant damage to the surrounding areas. The event is considered one of the largest and most destructive tsunamis in recorded history. Let's start with, what is a megatsunami? How is it different from the normal tsunami? Megatsunamis are distinct from regular tsunamis due to their exceptional magnitude and destructive potential. Whereas common tsunamis are typically generated by the movement of tectonic plates along plate boundaries, megatsunamis can result from a variety of natural phenomena, including landslides, volcanic eruptions, and meteorite impacts. Megatsunamis can be characterized by wave heights that greatly exceed those of typical tsunamis, with some waves measuring over 100 meters in height. The massive size of megatsunamis can result in devastating consequences for coastal regions, including widespread destruction of infrastructure, loss of life, and long-term economic impacts. The study of megatsunamis is an important area of research in the field of natural hazards, as it can aid in the development of strategies for mitigating their potential impact on human populations and infrastructure. Megatsunamis are a catastrophic natural phenomenon that occurs when a vast amount of material falls suddenly into a water body or any location near the water, for instance, by volcanic eruptions or meteor impacts. The enormous force of these events generates waves that are considerably more potent than ordinary tsunamis. The initial wave height produced by megatsunamis can reach hundreds or even thousands of meters, dwarfing the typical heights of tsunamis. The abrupt impact or displacement of the material in water results in a violent upward and outward splashing motion, culminating in the form of colossal wave heights that can cause unprecedented damage to coastal regions. The immense energy released during a megatsunami event can create a significant disruption to marine and coastal ecosystems, as well as pose a severe threat to human life and infrastructure. Therefore, understanding the dynamics and characteristics of these rare events is crucial for the development of effective mitigation strategies and the protection of vulnerable coastal communities. And here it comes. The Great Alaska Earthquake that occurred on July 9, 1958, around 10:15 p.m., had a profound impact on the Gilbert Inlet. This event was triggered by the sudden release of energy from the Fairweather Fault, which resulted in an earthquake with a magnitude ranging from 7.8 to 8.3 on the Richter scale. The geological shockwaves that reverberated through the region resulted in a series of events that culminated in the occurrence of the Lituya Bay Megatsunami, the most significant megatsunami ever documented. The seismic energy that was released during the earthquake resulted in a sudden uplift of the seafloor in Lituya Bay, causing a massive displacement of water. This displacement, in turn, led to the formation of a giant wave that rose to an estimated height of approximately 720 feet as it swept through the bay, decimating everything in its path. The Lituya Bay Megatsunami is considered to be the largest wave ever recorded in history. The Alaska Megatsunami was notable for its scale and the unique geological characteristics of the Lituya Bay area. The bay is located in a region characterized by steep mountains and deep fjords, which create ideal conditions for the formation of large tsunamis. In addition, the landslide that triggered the event was massive and occurred in an area with a high concentration of ice and glacial debris, which added to the overall size of the wave. Let's have a glance at Lituya Bay. Located on the northeastern coast of the Gulf of Alaska, Lituya Bay is a tide entrance that has been shaped by glacial activity. This ice-scoured bay stretches over a distance of 7 miles and has a maximum width of 2 miles. The depth of Lituya Bay is measured to be around 720 feet, but it is separated from the Gulf of Alaska by a shallow sill of 32 feet in depth that runs between La Chaussee Spit and Harbor Point. The geography of the bay reflects the glacial history of the region and is characterized by a range of features, including fjords, cliffs, and steep mountain slopes. The unique combination of glacial and tidal influences has resulted in a distinctive ecosystem in the bay, with a variety of marine and terrestrial flora and fauna thriving in this dynamic environment. Furthermore, despite its remote location, the Alaska Megatsunami had significant implications for our understanding of tsunami dynamics and the hazards posed by large-scale landslides. The event highlighted the potential for large tsunamis to occur in regions with steep mountains and deep fjords, and underscored the need for improved monitoring and early warning systems for coastal areas. The Alaska Megatsunami also contributed to ongoing research efforts aimed at better understanding the complex interplay between geological processes, such as landslides and earthquakes, and the generation of tsunamis. Moreover, the event underscored the need for improved monitoring and early warning systems for coastal areas, and highlighted the potential for large tsunamis to occur in regions with unique geological characteristics. Ongoing research efforts in this area will continue to build on the lessons learned from the Alaska Megatsunami and help to mitigate the risks associated with future natural disasters. The wave under consideration originated in Lituya Bay and impinged upon the land spur that separates Gilbert Inlet from the main body of the bay with such an unprecedented force that it entirely submerged the spur. This behemoth of a wave then surged across La Chaussee Split, traversed the entire length of Lituya Bay, and eventually flowed into the Gulf of Alaska. The aftermath of this tsunami was marked by the uprooting and displacement of an overwhelming number of trees, which were carried away by the force of the wave. And as the wave's intensity was the greatest, no trees or vegetation survived. This unprecedented run-up height of the tsunami and the extensive loss of plant life it caused marks a significant event in geological history, attracting the attention of researchers and scientists to investigate the underlying causes and potential implications of such a natural calamity. The bay is located in the northeastern region of the Fairweather Range, and its shape has been defined by the presence of the Fairweather Fault. The fault itself extends across the width of the bay, creating its distinctive T-shape. Furthermore, the presence of the Fairweather Trench, which is a large linear depression, has also been attributed to the fault's influence. Specifically, the weak spot in the fault has allowed for glacial scouring to take place, resulting in the formation of the trench. The Lituya Glacier and North Korean Glacier have also played a significant role in the shaping of the Fairweather Trench. These glaciers have caused considerable erosion in certain areas of the trench, particularly those near Lituya Bay. Additionally, the northeastern side of Lituya Bay is home to Gilbert Inlet and Crillon Inlet, both of which are located within the Fairweather Trench. The Fairweather Fault and the associated trench have been the subject of extensive research and investigation, as their unique features provide valuable insights into the geological history and processes of the region. The study of these geological features has yielded important information about the formation of the Fairweather Range and its surrounding areas, shedding light on the complex interactions between tectonic forces, glacial activity, and erosion. Overall, the presence of the Fairweather Fault and Trench and their associated features have contributed significantly to our understanding of the geological history of the region. So, what caused this mega tsunami? On a fateful day, an earthquake on the Fairweather Fault caused a rockfall of approximately 40 million cubic yards from the east wall of Gilbert Inlet. The impact of this rockfall was catastrophic, resulting in the formation of a massive wave that surged across the inlet. The velocity and mass of the falling rock caused the wave to rise to a height of approximately 720 feet on the west wall of Gilbert Inlet, despite the water's elevation being at sea level. The force of the wave was so powerful that it uprooted millions of trees along both the east and west shorelines of Lituya Bay, causing significant damage to the surrounding ecosystem. The wave then rushed through the bay and continued on to the Gulf of Alaska. The west wall of Gilbert Inlet was also overtopped by the wave, causing additional damage to the surrounding area. The sheer magnitude of the event highlights the destructive power of natural disasters and the importance of disaster preparedness and mitigation measures. The events of the Great Alaska Earthquake and the Lituya Bay Megatsunami were far-reaching. The quake caused extensive damage to infrastructure, including roads, bridges, and buildings, while the megatsunami destroyed large swaths of forest and coastal communities. This event serves as a reminder of the immense power of geological events and highlights the need for proactive measures to be taken to mitigate their effects on human lives and property. The reported events depict a tumultuous and surreal scenario. A glacier that had shattered into several pieces had lifted and descended to an altitude of several hundred feet, and a prolonged period of tremors followed. Then, a sequence of colossal waves, brimming with shards of ice, surged across the bay. An eyewitness recounted being hoisted over a wooded promontory, while observing the trees from above upon reaching the crest of a single wave. The wave was so forceful that it raised a lighthouse located at the mouth of the bay, as well as a residence on Cenotaph Island. Furthermore, a couple who were fishing when the tsunami struck was never found. The event in question is marked by a chaotic and bizarre scene, wherein a fractured glacier is observed to have ascended hundreds of feet into the air, followed by a prolonged period of intense shaking. Subsequently, a series of enormous waves, replete with ice chunks, inundated the bay. Moreover, the destructive force of the waves is evidenced by the obliteration of a lighthouse located at the mouth of the bay and a residence on Cenotaph Island. Tragically, a couple who had been fishing during the onset of the tsunami vanished without a trace. The observations recounted through witness accounts paint a picture of an event that was devastating and awe-inspiring, characterized by a tremendous force that wrought destruction on both animate and inanimate structures alike. And now, more than 6 decades after the occurrence of the devastating wave, its remnants continue to be observable from a satellite perspective. The trim line that suffered severe damage due to the tsunami is still apparent in the forest area. The false color Landsat 8 image depicted at the top of the page, using band 753, enables easy differentiation between younger forests represented by lighter green regions along the shoreline and older trees that escaped the wrath of the tsunami, evident from the darker green areas. Upon the tsunami's impact, all trees were shattered, and nearly all vegetation was destroyed, with the resulting damage covering approximately 2 square miles of woodland. According to the available reports, the event under consideration resulted in a total of 5 fatalities. In addition to this, several individuals were injured and displaced from their homes due to the impact of the natural disaster. Notably, 2 of the reported deaths occurred aboard a fishing vessel that was headed toward the bay during the time of the occurrence. Further reports indicate that the town of Yakutat, located in close proximity to the incident site, also faced significant damage to its infrastructure. Docks were destroyed, underwater communication cables were severed from the seabed, and bridges were wrecked. Despite the massive impact of the event, Howard Ulrich and his 7-year-old son, who were on board their fishing boat named Edry, miraculously survived. However, Ulrich witnessed the waves' arrival from the deck of the boat after he anchored the vessel in an inlet following the earthquake's occurrence. According to reports in the newspaper, Ulrich's boat was hit by a wave approximately 3 minutes after he first became aware of its presence. Despite his attempts to regain control, the force of the wave propelled the vessel towards the southern shore of the bay, only to be pulled back towards the center once again. However, this initial wave was just one of several that Ulrich and his child would have to endure before they could safely leave the harbor. These subsequent waves were said to have reached heights of up to 20 feet, posing a significant danger to the small boat and its occupants. The experience of Ulrich and his child highlights the unpredictable and potentially hazardous nature of waves in bodies of water such as bays and harbors. The power and force of such waves can quickly overwhelm even experienced seafarers, and the risks associated with navigating in such conditions should not be underestimated. In order to mitigate such risks, it is important for sailors to be aware of weather and sea conditions before embarking on any journey, and to take appropriate precautions to ensure their safety while at sea. Despite the passage of time, the vestiges of the immense wave are still discernible. When viewed from an aerial perspective, it is observable that a swath of destruction encircles the bay, spanning a distance of up to 700 feet. The zone in question remains a subject of intrigue for scholars, who continue to investigate its lasting effects. Lastly, Lituya Bay is a geologically complex inlet situated in southeast Alaska, characterized by its towering walls, bottom shape, and location across a fault that experiences frequent seismic activity. The unique features of the bay make it susceptible to the occurrence of future tsunamis. Despite the infrequency of large waves, a geological study that spans several years found that significant waves in Lituya Bay are observed once every 25 years, or roughly once every 9,000 days. Furthermore, the presence of tide currents, which prevented La Perouse from navigating the bay, posed a constant threat. The entrance to the bay has been known to claim at least one fishing boat on average per year since the 1958 wave. The continued occurrence of such events underscores the importance of continued research on the geology, hydrology, and oceanography of Lituya Bay to provide a better understanding of the potential dangers that it poses to maritime activities and coastal communities. And that's all for now. We hope that you found our video informative and thought-provoking. If you haven't already, be sure to hit the subscribe button and turn on notifications so you never miss an update from us. And remember, disasters can happen to anyone, but by coming together and sharing knowledge, we can build a safer and more resilient future. Thanks again for watching, and we'll see you in the next video.